Okay, this is just a textbook question taken from page 689, number 10. And the equation that we're given is that 2 hydrogen bromide gas react with to produce hydrogen gas and bromide gas. Initially, I only have product present in the container. So in this case, I'm actually starting with 0 HBr, and it tells me initially I have 0.25 moles of H2 and Br2 in a 500 ml container. So remember, we first have to convert that to moles per liter. But this is one of those examples where we have been given only initial concentrations of some of the chemicals, and we don't know anything at equilibrium. So we're going to have to use a bit of algebra to solve this one. So our first step is to figure out what these values are in moles per liter. So if we take 0.25 moles and divide it by the size of the container was 500 mils, so 0.50 liters, we get 0.5 moles per liter of each H2 and Br2. So we're going to sub that into our ICE table as the initial amounts. And initially I don't have any hydrogen bromide. So the only reaction that can take place here is the reverse reaction. And I don't know anything about the equilibrium values. So in this case, it's just a matter of subbing in and solving for an unknown. So there's 2 ways that you could look at this. You could say, well, here I'm starting with 0 HBr, so I'm going to end up with some X amount at the end. However, if we call this X, this would be plus X. The mole ratio here is 1 over 2. So if I times that, these would then be a half X, which kind of makes it a little bit awkward to deal with. So what I would do is call this a 2X, and then each of these will be a 1X. Okay, so at the end, I will have 0.5 minus X of my 2 products. Even though this is the reverse reaction happening, the H2 and the Br2 are still products of this reaction. So when I set up the Kc expression with P over R, I'm going to sub in H2 and Br2 as the products of this reaction. So when we set it all up, we're going to get, okay, we have the value for H2 and Br2. Those are both to the power of 1. Divide by HBr to the power of 2. So this is my equilibrium expression. Now we can sub in our numbers. Remember that when you're solving for equilibrium, we can only use equilibrium values, not the initial, not the change, only the values at equilibrium. Okay, so I know the value of Kc is 0.020, and this is equal to 0.5 minus X to the power of 1 times 0.5 minus X to the power of 1 over 2X to the power of 2. So if I simplify this a little bit, 0.5 minus X times 0.5 minus X is 0.5 minus X squared over 2X squared. So one way that we can simplify this quite a bit right from the beginning is get rid of those exponents. And how do we get rid of these squared exponents? We just take the square root of that entire side. So that'll cancel. Whatever you do to one side, though, you have to do to the other. So don't forget to square root this side. So square root of 0.20, or 0.02, sorry, is 0.1414. And that's equal to 0.5 minus X over 2X. Okay. Now if I'm trying to solve for X here, my first step is I don't want to have any X's in the denominator anywhere, so let's multiply to bring the 2X up to the other side. Okay, this will cancel on this side. 2X times 0.1414 Okay, we have to multiply 2 times 0.1414. So we get 0.2828x equals 0.5 minus x. Okay, now we just want to collect all our like terms, so I can do that by adding x to both sides to bring all of our x's to one side of the equation. Remember, the coefficient here is a 1 in front of this x, so 0.2828x plus 1x will be 1.2828x, and this is equal to 0.5. Our last step to isolate the x, we have to divide. And we get x is equal to 0.389. Guys, remember at this point, we're not actually finished yet because this is just our value of x. But if we go back to our ICE table, the values at equilibrium, of course, I forgot to write the 2 here. We have 2x, and then we have 0.5 minus x and 0.5 minus x. So I believe it was asking for the value of the hydrogen bromide at equilibrium. To do that, I have to take the value that I just found for x and sub it in here. So 2 times our value that we got for x, which is 0.389, equals, I believe if we round it, it's 0.78 moles per liter. So our final answer, we have to go back and substitute our x into the ICE table.